In this video, I'll be showing you how to use the Euler method to solve for an ordinary differential equation given an initial value problem. And so before we proceed, I recommend that you copy this table down here just so that it becomes easier when you want to input values later along the video. Or you can also download this Excel file, which I've shared in the description below. And so the Excel file comes complete with all of the workings already, but I still recommend that you follow through with this video to understand how we got those values. Right, before we move on, I think it's much easier to understand what we're doing here with the Euler method through an illustration. And so basically we have this person who's trying to climb up a mountain, and at the base of the mountain, x equals 0, we know that that person is at a height of 1. Now we want to figure out at the point x equals 2, when the person is on top of the mountain, what height is that person at? And this is what we're solving for here. At y2, what is that equal to? Okay. So here we're given our problem, which is the ODE, or the differential equation, and we're given the Euler method formula, and here we're given the parameters of the problem. So we have the point, our starting point is x0, which equals to 0. We have our initial value, which at point 0, y equals to 1. Hence, at point 0, the person's height is 1. And we have our step size, meaning each time the person climbs up, he takes 0.1 steps. So 0.1, 0.1, 0.1, eventually until the person reaches 2. And we want to measure the person's height between 0, the base of the mountain, 0, and the peak of the mountain, 2. Right, so with that, we can now proceed to the iteration table here. And so here, x1 is simply just xi at the first row is simply just 0 here, so link it to this cell. And we have our yi, and we know yi to be 1 here, because at x equals 0, y is equals to 1. So these are the initial values, and afterwards we can proceed with this column here, which is f of xi and yi, which is simply just the evaluation of this function here using these values, meaning it's just 0 squared plus 1. What we're doing here is basically just replacing the x and y values with our x and y values. And here, h of f of xi and yi is simply just the step size here, which you should $sign, multiplied by the evaluation previously, like this. Okay. And afterwards, we want to find the second xi, and it's simply just the previous xi plus the step size here, so right here. And don't forget to $sign it, because our step sizes are constant. And again, just if you forgot, what this basically represents is simply just how many steps the person takes at a given time. So at point x equals 0, the person moves to 0.1, 0.2, 0.3, 0.4, 0.5, and so on until the person reaches 2. And yi here is simply just the previous yi plus this column here. So press enter. The rest you can just highlight and copy down here like this, and from here it gets very simple. So all you need to do is just highlight everything, highlight it down, and copy and paste like this. Okay, and that is the Euler method right there. And so what we found out is, wait, let me fix this real quick. Okay, what we found out is that at the point of x equals 2, the person is at a height of 10.75, right? And so what's pretty cool about the Euler method is that we can predict, or we can model that at each position what height the person is at. So we know that initially the person is at a height of 1, and as the person steps forward or climbs up the mountain, it slowly increases. Eventually, the person reaches a height of 10.75. Right, that is it for this video. I have some other videos on other numerical methods, such as the Newton-Raphson, bracket method, bisection, fixed point, and so on. So if you need those or you're interested, please check them out as well. Thank you for watching.